Okay, today we're going to talk about algebraic limits. We talked about geometrically what happens in our previous lesson, and so now we're just going to talk about that with tables and with equations. The first thing I'm going to show you is with a table. Excuse me for just a minute. With this table, I have x values and y values, outputs, f of x. And let's say that the question that they wanted to answer was, what is the limit as x approaches 3 of f of x? And so in that case, you would start to look at the values in your table, and the x values get close to 3 on each side here. 3 would be right here in the middle of the x values. So you just look down on the bottom and see what's happening with the y values. Well, on this side, you're getting closer and closer to 5, and on this side, you're a little bit above 5, but as you go this way, you're closer and closer to 5. And so I'm looking for the y value that fits right in there, which would be 5. So that's how you read a limit from a table. Okay, now we're going to talk about some famous limits that people just know. And the first one we're going to talk about is limit as x approaches a of c. So this is approaching an x value, a, we don't know what it is, but it could be any x value. And c means that we would just have a number here. Well, think about the toolbox function where you have y equals c. That is a horizontal line. And every single x value on that has the same y value. And it's whatever that c is. So every x value that you could approach would have c as an output. And again, the limit as x approaches a of c equals c, famous limit. In other words, you should recognize it because it's a horizontal line. And so I would make that note to myself. Another one that comes up fairly often, especially in calculus when we get there, is the limit as x approaches 0 of sine x over x. And that limit is 1. It's just one that people memorize. It can also be upside down, so it could be the limit as x approaches 0 of x over sine x is 1. So again, that's just one you want to memorize. There's two more. The third one is the limit as x approaches 0 of cosine x minus 1 over x. That limit is actually 0. And then the last one is kind of reminiscent of the compounding when we did the exponential equations with money. And here, as x approaches infinity, it's 1 plus 1 over x to the x. And so if you remember, the more times, the x was kind of where the n was, and the more times you compounded it, the better. But if you did compounding continuously, it turned into an e. So that's what happens here. The limit of this is e. Okay, so here's some examples, especially with that one about sine. It is actually a pretty nice shortcut. If you have a matching set of information that you're trying to take the sine of and that's in the denominator or on the other side if it's flipped, if these two things match perfectly, then your limit is 1. If they don't, then, like number 2, there's math that needs to be done. And I'm going to teach you how to do that math in calculus step by step. But for right now, I want you, if they don't match, like in this one, we have 2x here and just 1x here, I want you to take the coefficient here and whatever the coefficient is here, and this is an understood 1, and make a fraction out of it. So 2 over 1 is 2. And so that's how I want you to get the answer for right now, and I will show you the math behind it next year. Okay, so look at 3 the same way that I was just talking about 1 and 2. They don't match. You don't have sine of 3x. You have a 3x on the bottom, so they don't match perfectly. So up here you have an understood 1 as your coefficient, and down here your coefficient of the x is the 3. So that will be 1/3 as your limit. And then number 4, we have the limit as x approaches 2 of 7. This is our horizontal line at 7. So at 2, the y value would be 7. It's just an understood thing. Okay, now for the everyday problems. The ones that we were just talking about are kind of special cases. Your everyday problems, the first thing that you're going to try to do is to plug in. So whatever the x value is, you're going to try to plug it into the formula that they give you and try to get an answer. But you don't always get an answer. Sometimes you get a 0 on the bottom of a fraction, which you know is not allowed. So I'm going to put a note here. If you get 0 on the bottom, so in the denominator, then you go to step 2. Because if you get an answer, you're done. So if you get a 0 on the bottom of a fraction, you move to step 2, which is try some algebra. Now, at this point, you've had a lot of algebra in your background. They expect you to remember all of it. So things that you might want to do are factor and cancel. You may want to get a common denominator. You may want to multiply by a conjugate. Now, how do you know which one? You don't. That's why you need to look at the problem. You need to see what it looks like you used to do with those kinds of things and try something. And it may help and it may not, but you have to keep trying. These are common ones. Another common one is to have a complex fraction like we went over the first couple days, and in that case you would multiply everything by the common denominator and you would be able to reduce there. Other times you get a common denominator and combine two things. So it's up to you. Try something, see if it can work. Then if all else fails, you graph it and you look at it like we did in the previous lesson and try to answer it graphically. Okay, here is our first example. And I have the limit as x approaches 3 of this rational function, and as always I try to plug in first. The first place I'm going to plug in is the bottom to make sure I don't get a 0. So if I plug 3 in, 3 plus 9 is not 0, it's actually 12, so I'm going to come over here and write that down. That means I don't have to do the steps 2 or 3. I can probably plug in and get an answer here. So now if I plug the 3 into the top, I'm going to get 24 on top, and then 24 over 12 will be 2. So my answer to this is 2. The limit as x approaches 3 of this function is 2. Okay, for our next example, when we look at it, the first thing that you want to do again is try to plug in. If I plug negative 2 into the denominator, I'm going to get a positive 4 plus a negative 2 and minus 2. That's going to give me 0 on the denominator. That means I have to move to step 2. I can't just plug in and get an answer here. So this reminds me of the rational functions where we factored and canceled. So that's what I'm going to do. I'm going to come over here, I'm going to factor the top, and this is your x factor factoring. So x plus 2 and x minus 3. Then I'm going to factor the bottom, be x plus 2 and x minus 1. And since I have something that will cancel out, I'm going to cancel out, and then I'm going to plug in. So now I'm going to plug negative 2 in for this x and this x. So negative 2, excuse me, that should be a minus 3. Minus 3 over negative 2 minus 1. And that's going to give me a positive 5/3. So that's my answer for this one. Okay, there's example 7. We're doing the limit as x approaches 16 of 16 minus x over 4 minus the square root of x. And if you plug in 16, you get a 0 in the denominator again. So we'll have to do some algebra. This should remind you that anytime you have square roots, in the past we have rationalized our denominators. We've gotten rid of that square root by multiplying by the conjugate. So again, I'm going to multiply by the conjugate. I'm going to say 4 plus the square root of x and multiply that on top and bottom. One thing you will learn about these is this doesn't have to be just doing the conjugate of the bottom. If this fraction were flipped, we would still be in the same position. We would have 16 minus 16 on the bottom. And you can actually multiply by the conjugate of the top. Okay, so what happens here, I'm not going to multiply out the top. I'm not going to FOIL out the top. I'm going to put 16 minus x in parentheses and keep my 4 plus the square root of x in parentheses. I am going to multiply out on the bottom. So 4 times 4 is 16. 4 times the square root of x is 4 square roots of x. Negative square root of x times 4 is negative 4 square roots of x. And negative square root of x times the square root of x would be a negative x. And again, I haven't messed with the top, so I'm going to keep it the same. When you look at the bottom, however, these two middle terms should cancel, as they always should with conjugates. And you have 16 minus x left. And those will cancel. Now that you have kept that separate, you can see that. And you have 4 plus the square root of x. Now that's not your answer. We haven't plugged in yet. So I need to plug the 16 in. 4 plus the square root of 16, that gives me 8. And 8 is my answer. Okay, this is my last example for you. And again, always start by plugging in, and I always start by plugging into the denominator. So negative 2 cubed is is negative 8. I'm adding that to a positive 8. That will be 0. That tells me I've got to do some algebra. Well, this one actually factors, and you'll have to remember how to factor your perfect cubes to get this one. So the top stays the same. The bottom factors into little parenthesis and big parenthesis. And then we do first thing, second thing, first thing squared, product of the two, and the last thing squared. This is like that one. This is the opposite, and the last one is always positive. So once you have that factored, you will see that the x plus 2's are now going to cancel. And you have 1 over x squared minus 2x plus 4. And I can plug in the negative 2. So 1 over negative 2 squared minus 2 times negative 2 plus 4 is going to give me 1/12. This concludes this video. You can come see me for your assignment.